would be nice if I could shoot this video about the sun on a nice sunny day, but you know the weather in New England, it's a little unpredictable sometimes. Well, I hope wherever you are today, the weather is great. And the weather, of course, relies upon, as I said, the sun. Now, the sun is always shining on the earth. It's just a matter of whether or not there are clouds over where we happen to be. But have you ever stopped to think, how does the sun shine? And will the sun shine forever? Well, in week 8, we're going to start studying those questions, but they'll be continued further on into following weeks. So I have here a little model of the sun. I have little kids make these. It's a styrofoam ball, about 4 inches wide or so. And I've painted it yellow to represent the visible surface of the sun, the part that you're not supposed to look at with your eyes, remember? The photosphere. So the light that we receive from the earth is emitted from this layer called the photosphere. But there are interior layers of the sun as well, and that's where all the magic happens. That's where the nuclear fusion occurs that converts hydrogen into helium. So you're going to be learning about fusion cycles. You're going to be learning about how the sun converts hydrogen into helium, and in doing so makes energy that we receive as sunshine. You'll also notice that I have toothpicks on the top and bottom. This is to represent the fact that the sun rotates on its north and south pole, just like the earth rotates. And as the sun rotates, we see different sides of it. And on the surface of the sun, I say surface in jest because, again, it's a ball of gas, it's not solid. But on the visible surface of the sun, you can see that I have represented different areas of activity. There are darker areas and brighter areas and these weird red things that stick out. And the darker areas you may have heard of, they're called sunspots. The brighter areas you might not have heard of, they're called faculae. And these red handles represent activity, which is called prominence. And all of these kinds of activity and other kinds are all interrelated. They're related to the sun's magnetic field. And over the course of approximately 11 years, the strength of the magnetic field waxes and wanes. You'll learn about that from reading the book. And every 11 years, the magnetic field has to sort of reset itself. Now, because of this, there are differing numbers of sunspots and faculae and prominences all the time. And you might say, well, that's nice. We're not supposed to look at the sun, so why would I care? Well, you would care as an average citizen because the activity of the sun actually has effects here on the earth. And so in this week, you're going to learn about something called space weather. You're going to learn about how outbursts on the sun can directly affect our lives here on earth. On the positive side, it creates something very beautiful, the aurora borealis and the aurora australis, the northern and southern lights. Not so good? It can fry communication satellites. Think about that for a minute. Think about how that would put a damper in your day. So the sun gives us more than mere sunlight. So hopefully you have a nice sunny day. If you don't have a nice sunny day, pull out the book and learn about the sun.